So we understand that in monolithic, when we have huge requirements, it is not possible to deploy parallel teams and work and deliver huge requirements at a time by working with 4 or 5 teams. It is impossible to deliver all the tasks together, because integration will take in place there. Again, we need to integrate all teams code together, and we should make it a single application before deploying it. So to overcome the monolithic challenges and to develop parallelly independent features and deliver them without depending on other teams, microservices are good. So each microservice very small in size, each independent task or a feature or a module we can design as a microservice, and it is recommended to use for each microservice one separate database, one database for each service. As soon as your services count increases, your databases also will increase, and lot of configurations also you need to maintain. Just from database side, lot of configurations you need to maintain across all your microservices. Earlier we used to have one single database, one single application, so easily we can able to do the configurations in our properties file of one database, and whenever changes required we can easily change. Consider here I have the microservices count up to 25, and same way I have databases. I have databases also here. Just a minute. Yeah. So where do we need to maintain all these databases references? Let's say if it is A service and it is B service and so on, XYZ services I have here, and same way I have databases for each service. Usually we used to maintain them in application itself, in properties file. In application properties file, usually we used to maintain all these properties. If it is a normal monolithic scenario, we maintain all the properties related to this DB under this properties file, all DB configurations, other stuff. Same story with all the services. If you don't know this config server concept, the centralized configurations concept, we generally prefer to maintain these configurations under local file itself. So A service will maintain ADB, B service will maintain B database, DB configurations here in local itself. Every microservice will maintain the responsible database properties under its properties file. But as soon as microservices counts continuously increases, right? For every new feature or for every module, I'm picking up a new microservice, and there if I maintain my database properties, again if you remember the properties not fixed to each not fixed to all the environments. For each environment again we have different set of properties. For local we have one local database. When we shift our code to SIT, there we will have again one more database. Their testers will use that. And for end user testing we will move our application to again UAT. There in UAT we need to maintain again UAT properties. For production properties. Each application again itself will have at least 4 different configurations. If I maintain everything in local, it will be very difficult to maintain all these 25 applications. Consider there is one scrum master or one manager, or you may say one technical architect or a technical lead who is leading all these 25 applications. For them it is difficult to manage the properties by every time going into these local properties and making changes, and they need to remember all the you know applications and what are all configurations that you have made as part of that application. And if there is a change, let's say across all these applications, there is a common change, a common property that I'm using, I need to change. So instead of doing in one place, they should go to each and every microservice and they need to change that property, and they should have done redeployments and testing. So a lot of cycles again they need to reinvent here. Instead of that, instead of maintaining properties locally in microservice, it is preferred to use global properties. Instead of maintaining it under local, you may maintain that properties under a central config server. You can use a config server, a separate microservice, config server microservice. There you can maintain properties. There you can maintain properties. Till this config server, it's again a microservice. Again, you can create a microservice config server microservice. Here you can put all the environments, all microservices configurations for all environments, for all your microservices, and for all your environments. Each microservice for all environments, you can maintain properties here. And each application can now, instead of coding your properties under application properties file, from your application properties file you can refer to this config server application. You may refer to this config server application. So when you start your microservice, it will pick properties from config server, a central server. So across all 25 services now, they will start using or fetching properties from a central config server instead of local properties. So the advantage is here, whenever you want to do changes for A application or for B application or for common changes, you can directly visit this config server. There you can do the changes. So you have now control centralized. You go here and you can manage your properties. You need not to visit your microservices. And still here, you need not to maintain them in local. This config server can fetch properties from any repository tool like Git or Bitbucket. You can use any repository tool, Git or Bitbucket. You can create one repo. You can create one repo in Bitbucket or Git. You can create. Under that repo, you can create your properties file. Under that repo, you can create your properties file, application properties. In one single properties file, we can have all the configurations. You can use one properties file, or instead of one properties file, you may use YML file, or for each environment, you can maintain one YML or one properties file. Okay, there are multiple styles. Okay, so consider I'm using one properties file here. This properties file is having all applications. If it is difficult to maintain in one properties file, you can maintain multiple properties file. Okay, for each environment, you can create one properties file with environment extension. Okay, so let's say for development or for local, if you need one properties file, you can create local dot properties. So when you give your profile name as local, it will pick up local properties automatically. Or you can give YML properties or OML, both it will read, properties or OML. So for local properties, and for production if you want to maintain, or for SIT properties, UAT scenario, UAT properties, and production. For each environment you can maintain one separate properties file also in repository. Create a repository, there you can create all your properties. And your config server can fetch properties from the given repository. Just you need to give your repository URL here. If you mention your repository URL from your repo, it will access. From your repo, it will access all the properties. Okay. So to access it, you need to have permissions. Maybe wherever you are running this config server should have access from the repo, so that you can able to fetch the properties. Usually, I'll create a public repo so that I can able to access into my config server. Okay. So once config server getting all these properties here, it is ready to distribute. So to create config server, what kind of microservice I need to create means simple Spring Boot microservice only. Using Spring Boot, you need to create a service with a Spring Cloud config server dependency. You need to add config server dependency. Spring Boot config server dependency you need to add. That's it. And you can choose any port number to run. You can choose any port number to run. The default port they recommend is 8888. But it's your wish. You can use any port number. So once you create this config server, just by configuring your repository URL, all these properties it will load into this config server. Now your microservices can access from here. Whatever microservice you implement, you can access them here. For that purpose, in your microservice, you need to add config client dependency. Config client dependency you need to add. Apart from all other dependencies, right? Web dependency or JPA dependency, you need to add config client dependency. And here you need to mention your config server URL. In this microservice application properties file, you need to mention your config server path. Your config server path you need to give here. Your config server path. Your config server path you need to give here. So whenever you start your application, whenever you start this microservice, it will refer properties from this config server path. It will visit config server. From there, it will get properties. From where config server will get the properties? From repository. Config server will get properties from repository, and your microservices will get properties from config server. Now, as an admin, or as a technical lead, or as a scrum master, or an architect, if you want to maintain all these microservices properties, now you have a single place to manage them. You have a single place to manage them. You can visit this place and you can manage them. You can able to manage them easily. Similarly, in cloud, right? In cloud, like Amazon or AWS or Azure, they given key vault to maintain such properties. In key vault, you can maintain properties so that only admin can able to see them. While sharing it, it may share to config server or microservices in a decoded format, or they can't directly see the properties. Somehow we can hide the properties from others. So using key vault also we can maintain them. When you use cloud concepts, right, a similar thing is available using key vaults. So under that key vault you can put all your properties. From there you can refer to your config server and you can fetch the properties into your microservices. Okay. Azure Key Vault. In AWS, it is key store, right? Azure, uh, Let's check it. Azure having key vault concept. Yeah, maybe you can try this. It will, even the good thing in Azure is they will give you code also how to access these keys from your microservice. Start free. Two, one, six, five. No, credit card verification is mandatory. Later I'll do the sign up process. Okay. So key vault we can create in Azure and AWS vault. Yeah, similar concept available in AWS as well. So generally, whichever service the client is using, there we can create all these key values and we can fetch them. Okay, but this one is from belongs to Spring itself. You need not to depend on any special cloud service. You can have your properties in your local, I mean, in your organization repo itself. You can use, but whatever properties has been shared in this properties file, they are public. Everybody can see. If you don't have that much restrictions, right, if it is internal kind of application, you need not to depend on it. But if everybody doing this practice, you need to go with the same practice. So across the organization, same company, other teams are using keywords, maybe you need to adopt the same. But if there are no restrictions, you may need to, or you can create in your repo. Okay. Yeah, let me show you this. So yeah, 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 every cloud service must be providing this, maybe GCP or other cloud services also should have similar concepts. That is very important, right, to maintain applications secrets. Yeah. So here we have added Spring Web config server. Yeah. So one dependency added config server. So just to maintain configurations, centralized this config server application created, and as part of this application properties, excuse me, we have mentioned server port 8282, but it's up to you. Okay, you can maintain any port number. And Spring Cloud config server git URI. If you are using git, you can pass the git URI here. And as an alternate bit and bitbucket svn, I think other options also given here, you can explore. Secrets manager, AWS access given, Azure path also given, key vault MSI path if you can given, from there also it will fetch. So wherever you put properties, either Azure or AWS, GCP, GCP also you can use GCP path, GCP vault path. So just we are trying to accessing it from Git, or you can give Bitbucket, SVN base directory, SVN access given, Bitbucket. I don't see, maybe using Git URI itself you may pass here Bitbucket path also. It might allow you. Okay. So, but lot of options you have here. Git you can access, AWS you can access, Azure you can access, GCP keyword you can access. From any place you can access your properties files or properties into your config server first. Okay. So here I have one path. Okay. Git path. Here I have few properties. You can create one repository in Git. Okay. You know right how to create Git account. So create and create one repository. I created one config server with any name you can create, and one properties file I created as part of it, application properties. And here I have some properties. If you see multiple profiles I'm using here using hash and dash 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 operator. Here I have SIT properties, and above I have dev properties. Okay, you can maintain any number of environment properties here. Okay, for each environment, if you have different database configuration, different URL, all that stuff you can maintain here. Okay, so consider I'm using admin schema here and admin SIT schema here. Okay, so what I would request you is create a brand new repository, one more new repository, and maintain properties. For now, let's see. I have some data source URL, username, password, and connection pool properties. Uh, Nothing much, simple database properties only I have here. Okay, and here also I have some database properties, two environment properties I have there. Let it be any number of properties, right? So all that properties it will load into this config server first. Okay, as soon as I start this config server, what it will do, it will fetch properties from Git. So the config server application is started. Config server application is started. And it will hold all the properties from Git repository. How we can fetch them now? So leave this. It is started and it is running. Now let's see a client need properties which are being available here. So this properties my config client is required or my microservice is required. So what I need to do here is in my microservice, that means across all your 25 microservices as per this example, across all your 25 microservices, right? You just need to put this config import statement, config import config server path wherever it is running. It is running in localhost 8282, so I given that path. If it is a different path or remote path, you need to give that host and port number. So now, as I mentioned here, all the properties it will import here. Which properties? all the properties from config server. From where config server getting the properties? Getting it from this Git repo. So all Git repository properties, now it will make it available to this 9090 running application. And while loading, we are specifying the profile as well here. Profile name SIT. So as I mentioned, profile name SIT, which properties it will fetch? SIT properties only. Wherever the Spring config active on profile is SIT, so all that properties it will fetch. So only SIT properties it will fetch. If I don't mention anything, it will fetch all the properties, and you need to mention the profile to utilize them. So as I given SIT properties only it will fetch. Now for that, this is your path, config server path. Config server is running in this 8282, na? Your local consumer one. This is your server one, config server, where you have already properties loaded. This server one, this server path we need to give, right? As I said, config server path. So in your local service, you need to give that config server path. From there, it will import them. Okay. So for that, what you need to do, just you need to add one enable discovery client with the dependency same Spring Cloud starter config you need to add. For config server, we have used, I think, Spring Cloud config server. So you need to add simple. Here we added config server, Spring Cloud config server. For client, we are using Cloud starter config. This is for config client. You can see the difference. Spring Cloud starter config, Spring Cloud config server. Starter config is for config client, config server is for server only. Okay. Server application will have this dependency, and client applications will have this dependency, starter config. And in client application, we are using enable discovery client so that it can able to allow the properties from config server. Same way, one more annotation we have used under config server application. Enable config server. Enable config server. Okay, that's it. Nothing much implemented here. Now see how config client will fetch the properties. Okay, config client, how it will fetch the properties, you can see here. Okay, I'm using a simple REST controller, and I'm trying to, when I do get data, I'm trying to return a URL username password, and this URL username passwords I'm loading by using this property spring dot data source dot URL, spring dot data source dot username password. Using at the rate value, I'm trying to loading that properties here. From where these properties will come in local, they are not available. This application local properties are not having that data source URL username password. Even your config server also doesn't have them. If you go to config server, in config server also we don't have them. But config server is reading that properties from this Git. From Git, it is reading. In Git, they are available here. So these properties it will read and it will make it available to you. So just run and see your config client. Yeah, just 2 more minutes, guys. Okay. So the config client started. Just see what data we have here. It is running in port number 90. Is it 9090? Which port? 9090. Okay. So 9090 slash get data. So when I call get data, it is printing my URL, username, password. But if you observe here, 9090 service locally, we don't have that properties. Maybe it is delaying your screen. Others, are you able to see this browser? Yeah. So basically, these properties now you can see these properties are coming from Git. Whatever Git properties you have here, right? That Git properties came to my microservice via config server. Via config server. Tomorrow I'll try to sign up the account, okay, to Azure Vault, and if possible, we will see this in Azure Vault as well. Okay, I'll try to do that. I'll sign up and try. No, no, client application 9090 is client application, right? Not the server one. It is client one. Okay. So in client, I am able to see these properties, but how they are not there? These properties are coming from config server, and config server also doesn't have these properties. That is getting from Git repository, right? Imagine this scenario, okay? So when you need to, hmm, uh, yes, not concretely, but yeah, 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 kind of expressions only. Using this simple expression, we are getting them. Spell is having a lot of features again. Even object we can create on the fly in the expression itself. Collections also we can create. Okay, okay, yeah, don't deviate. So just using value, and by using this dollar expression, we are fetching these properties. Just mentioned key here, it is able to get the properties. Okay. So tomorrow what we will do, we will create two microservices. Okay, like one student service and one books service, and for that common properties we configure. Okay, using YML style and properties style, and uh, again we will see one bit client, bit bucket, and one Git client, and if possible one Azure uh, Vault also we will see. Okay, again the same example we will do tomorrow more in detail. Okay, yeah, that's it for today. Okay, tomorrow we will log in little early. Okay, from tomorrow I'll mention the time. Please, join. So we will discuss for 1 or 1.5 hours. Okay, yeah, this one examples. Yeah, examples I'll share. Already for previous batch I believe shared the same route. I'll share it with you. Okay, just look into these two examples. Okay, this is the first example. Nothing discussed before. Okay, as part of microservices. So just go through it. I'll share that path. Okay, in our group. Yeah, yeah. Git path, right? Git path anyway in example that is available in your properties file. Okay.